Have you ever wondered how sustainable buildings are built? Our world is evolving, and with it, the way we construct our buildings. The importance of sustainable buildings is growing as we recognize the environmental impacts of conventional building materials. Did you know that materials like concrete, steel, and aluminum are responsible for nearly a quarter of global emissions? But we're finding ways to reduce these emissions. By thoughtfully selecting our materials, we can build structures that not only stand the test of time, but also respect our planet. For instance, we can modify concrete with fly ash and slag, recycled materials that not only improve the structural durability, but also reduce carbon emissions. We're also seeing the advantages of aluminum structures with their high load-bearing capacity, excellent corrosion resistance, and lower maintenance requirements. As we can see, the construction of sustainable buildings begins with careful consideration of the materials used. In the quest for sustainability, architects and engineers are harnessing innovative methods and technologies. Let's delve into some of these cutting-edge approaches. One such method is the combined heat and power (CHP) system. This system generates power, heat, and chilled water for air conditioning all at once, using high-efficiency technology. It's particularly beneficial in densely populated humid cities, where it offers significant cost savings and reduces carbon emissions. Then we have the building envelope, a structural solution that acts like a skin, creating an intermediate layer between the building's interior and exterior. This dynamic facade serves as a filter, allowing in sunlight and ventilation, but providing shade when needed. It ingeniously harnesses wind movement between the interior and exterior environment for passive cooling and ventilation. The result? Improved air quality and enhanced well-being for occupants. Let's not forget about self-draining glass. This innovative material, made from nanomaterials and installed on building exteriors, absorbs heat energy from the sun and converts it into electrical energy. And then there's solar skin, developed by engineers at the University of Queensland. This surface is created with nanoparticles called quantum dots, which pass electrons and generate electric current when exposed to solar energy. The beauty of this technology is that it can be printed on any flexible surface, allowing it to be applied to windows and other surfaces to harvest natural energy, even on cloudy days or in cities with weak sunlight. Other greenfield design aspects worth mentioning include heat-reducing facades, circuit-embedded windows, electric curtains, and naturally ventilated roofs and tiles. All these features contribute to reducing energy consumption and boosting occupants' wellness. In essence, these innovative methods are redefining sustainable building design. They're not just about constructing buildings that are energy efficient and environmentally friendly. They're about creating spaces that enhance the well-being of the people who use them and that seamlessly integrate with their surroundings. These innovative methods are pushing the boundaries of what's possible in sustainable building design. So, how exactly are these sustainable buildings built? Well, the journey of sustainable building construction is a fascinating one, and it is typically broken down into 4 clear steps. The first phase is mapping requirements with availability. This is where the planning process begins, with the identification of what exactly needs to be built. This includes listing the requirements, pinpointing features that are conducive to the building's location and the city's climate. A key part of this phase is also to exploit locally available resources, integrating the gray with the green. The next step is strategy formulation and modeling. Here, architects and engineers develop a sound strategy, creating a building information model or BIM. This model helps to understand and evaluate the outcome of the plan before its execution, saving time, resources, and preventing monetary losses. The third phase involves creating a blueprint for implementation. While the BIM serves as a guide from planning to implementation, a detailed blueprint based on the observations from the BIM is essential. This blueprint acts as a roadmap, directing every step of the construction process. The final phase is operations management. This involves the management of the complete structure, a task that is done through a combination of the building management system, the operations management, and digital twin technology. The digital twin of the greenfield building provides a real-time, holistic view of the structure, assisting in its efficient operation. Through these steps, the construction of a sustainable building becomes a systematic and well thought out process. It ensures all aspects of sustainability are considered, from the choice of materials and design to the ongoing operation of the building. By following this process, architects and engineers can ensure that the final building is not only sustainable but also efficient and comfortable for its occupants.